Apple Rubber is always focused on putting the customer first. We take pride in making sure each product is precisely what the customer expects, maximizing the likelihood that customers will always receive parts that meet their specifications. To minimize the risk that parts do not meet customer requirements, we take our time to thoroughly test each material and sample each product for both qualitative and quantitative requirements. The quality testing process starts and ends with our Form F39, which we refer to as the Pink Sheet. This is an internal Apple Rubber document that works as a checklist to record and document quality information. We test everything for quality, from raw materials to finished products. This is a confirmation for our customers that they are receiving parts that meet their specifications. The first test for raw materials is a Production Process Analyzer, or PPA test. This machine allows us to analyze and control our rubber compounds. From there, we continue through tensile, density, and finish off with FTIR testing. After analyzing our rubber compounds, we move into tensile testing, which quantifies a material's physical properties. This test is especially important when testing a raw material, because engineers can see which material works best under specific conditions. Then, when it's time to build a seal for a particular application, we already know which materials to use. Tensile and elongation are usually based on ASTM D2000 callouts, but this can change based on customer requested ranges. In order to properly measure tensile, there is a specific area on the seal that is used to calculate the force. Complex shapes don't have a set area to test and typically don't fit into test fixtures, so this test cannot be performed on those products. In this case, testing raw materials first before engineering the products is extremely important. After tensile testing is complete, we move into specific gravity testing, which is done by comparing the weight of a dry rubber specimen to the weight of the specimen when submerged in water. The specific gravity of rubber is determined by high-precision analytical balances, as per ASTM method D297. These balances use scales that are extremely accurate, which is important when testing something like micro wings that have extremely low weight. Since most rubber is black, it sometimes is difficult to decipher between materials with the naked eye. This is where density testing comes in handy, because different types of rubber have very specific gravities. We can easily make sure we're using the right material using this test. Some of our most popular rubber compounds include Viton with a density of 1.87, nitrile with 1.2, and neoprene with 1.47. It's easy to see based on these numbers how each rubber compound has unique density, and their density ultimately plays a role in how much these materials cost. Parts with higher density typically have a higher cost. A part with higher density also weighs more, so shipping costs can be affected as well. Last on our checklist is the FTIR test, which is used to identify organic, polymeric, and inorganic materials and material families. This test is typically used for a final product to ensure the rubber part was made from the correct material. This test is also useful for raw materials to make sure the correct formulation was used to mix the rubber. During an FTIR test, the laser converts the detector output to an interpretable spectrum. Then the FTIR generates spectra with patterns to provide important structural insights. The results of this test will give us the qualitative analysis of rubber, which is important information to know when building seals. Finished rubber parts are tested a little differently. The parts undergo a visual attribute inspection to ensure the surfaces of the rubber parts are acceptable. Inspectors review the parts for surface defects, like knit lines, non-fills, and foreign material. Unless required by a customer, visual attribute inspection follows our standard sampling plan. For example, medical product is sampled using a 0.65 level 2 normal AQL. Then, the geometry is reviewed to ensure the parts meet dimensional requirements. After that, durometer, tensile, density, and FTIR testing is conducted. Laboratory tests follow our laboratory testing sampling plan. For example, O-rings are measured for geometry using the C=0 4.0 AQL plan. After the finished rubber products are sampled for visual defects, we start our testing process. A sample of the finished product is taken to begin dimensional verification using a non-contact measuring machine like this MicroView. Once programmed, this machine will automatically measure the product for the right dimensions. Since the machine is automatic, there is a low risk for mistakes, and dimensional inspection takes less time. It also ensures measurement repeatability and reproducibility, which can be verified through a gauge R&R. Measuring the geometry of specific features is particularly important for seals because it gives Apple Rubber and the customer confidence that their products will meet their expectations. All test data is compiled and reviewed to ensure the part meets the specifications to ensure positive material identification. After running through all of the tests, our pink sheet should be complete with any information we need. The results from the pink sheet are entered into our quality module of our ERP system and created into the certificate of conformance that each of our products receives. Since all of our products leave our facility with a certification, customers can feel confident that their products are high quality, reliable, and meeting their expectations. That's what we here at Apple Rubber strive for every day.